Hello everyone, I am Sharani. Welcome to my channel. Today in this video, I am going to explain about real numbers. Introduction of real numbers. What are real numbers? Real numbers are the combination of rational and irrational numbers. So, what are rational numbers and what are irrational numbers? Rational numbers means the numbers which can be expressed in the form of p by q, where q is not equal to 0. Those numbers we call it as rational numbers. And irrational numbers means the numbers which cannot be expressed in the form of p by q. Those numbers we call it as irrational numbers. And rational numbers are represented by the letter capital Q and irrational numbers are represented by the letter capital S. And real numbers are represented by the letter capital R. Starting letter capital R. Here the combination of rational and irrational numbers. Rational numbers and irrational numbers. Irrational numbers. Rational numbers are in the form of p by q, where q is not equal to 0. This is the condition. And these are represented by the letter capital Q. Q is in the form of p by q, where q is not equal to 0. Here the condition is the q is not equal to 0. And rational numbers are represented by the letter capital Q. And irrational numbers are represented by the letter capital S. Here the numbers which cannot be in the form of p by q, those numbers we call it as irrational numbers. So rational numbers are represented by the letter capital Q and irrational numbers are represented by the letter capital S. Here the examples of rational numbers. So rational numbers means all numbers, natural number, whole numbers, integers. Already we learned, these are all in the previous classes, we know that. So integers means, what are integers? Positive numbers, negative numbers and including 0. The set of these are all numbers we call it as integers. And natural and whole numbers. Natural numbers means 1 to infinity are natural numbers. Whole numbers means including 0 the natural numbers. That means start from 0. 0, 1, 2, 3 and so on. These are all numbers we call it as whole numbers. Integers means positive numbers, negative numbers and including 0. These are all we call it as integers. That means these integers and natural numbers and whole number comes under rational numbers. Whatever the numbers we cannot represent in the form of p by q, those numbers. Next theorem is fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? Every composite number can be expressed as a product of primes and this factorization is unique apart from the order in which the prime factors occurs. What is that? Every composite number can be expressed as a product of primes, composite number and prime numbers. First, you should learn about composite numbers and prime numbers. What are prime numbers and what are composite numbers? What are prime numbers? These numbers, prime numbers have only two factors. Those numbers we call it as prime numbers. For example, here 3, 2, 3, 5, 7. These are the examples of prime numbers. What are prime numbers? These numbers only have two factors. Simply we can say that the numbers which cannot be divided by any other number. So these numbers we call it as prime numbers. These numbers have only two factors. 1 and the number itself are the factors. What are factors? 1 and the number itself are the factors. Examples are 2, 3, 5, 7. That means suppose 2 is the number. Into any the number is divisible? Is any number divisible into? No. 1 only divisible. 1 is divisible in all the numbers as well as the same number is also divisible in that number. So 2 is the number itself is divisible. So whatever the numbers are divisible. So those we call it as a factors. So what are the factors of 2 means? 2 factors are, what are the factors? Factors of 2 are, what are those? 1, 2. Any other number is divisible, which number it divides this number means those are factors. So next 3 factors of 3. What are factors of 3? 1 is divisible, so 1 is a factor. And is 2 divisible in 3? No. Why? Because 3 is an odd number and 2 is an even number. So that is not divisible. 3 is divisible. 3 is divisible in this number 1 time. So whenever it is divisible, that is a factor. So 1 and 3. 1, 3. 1 and 3. Why? Because only 2 factors. 1 and 2 as well as 1 and 3. Like that, factors of 5 are. What are those? 1 and 5. In 5 also any other number is not divisible. 1 is divisible as well as the same number is also divisible. These numbers we call it as prime numbers. So prime numbers have only 2 factors. Those 2 factors are 1 and the number itself are called as number 1 and the number itself. Those 2 only the factor. Those numbers we call it as prime numbers. So here every composite number. What are composite numbers? Composite number means the numbers which have more than 2 factors. It is the number which have more than 2 factors are there. Those numbers we call it as composite numbers. For example, here 4 is a number. Factors of 4. Factors of 4 are, in 4 which numbers are divisible? Just you have to check it. Is 1 divisible in 4? Yes. Is 2 divisible in this? Yes. Why? Because 2 2 is 4. This is an even number. In all even numbers 2 is divisible. So whenever it is divisible, that is also a factor. 2 is divisible. Is 3 divisible in 4? No. Is 4 divisible? Yes. The number itself is divisible. So 1, 2 and 4 are the factors. 1, 2 and 4. How many factors are there here? 1, 2 and 3. 3 factors are there. So simply we can say that this is a composite number. More than 2 factors are there. Those numbers we call it as composite numbers. So every composite number can be expressed as a product of primes. Those numbers, and this factorization is unique to all different factors you will get for each and every number. So apart from the order in which the prime factorization. Do you know that prime factorization method? By using the prime factorization method, we can find out the factors of the given numbers. So how can you find out? For example, here C. By using the prime, this is also you have learnt in the 6th class. And 5th class also, in the 4th class also already is there. For example, here 24 is the number. So the prime factors, so by using the prime factorization method, find out the factors of the given number. You have to find out the factors of the given number by using prime factorization method. For example, here which numbers are divisible in 24? 24 is a given number and next number is 27. For those 2 numbers, you have to find out the factors by using prime factorization method. So just those factors also prime factors only. That means the numbers are only the prime numbers. So you have to divide only with the prime numbers. So 24 first number you have to consider. In this number, which number is divisible? First you have to check it. 24 is the even number, so 2 is divisible. All even numbers are divisible by 2. So 2 is a number. 2 is divisible into 1 time as well as in 4 2 times. That means 2 12 yeah 24. Right. Again here 2 6 yeah. Again 2 3 yeah. Like that you will get the factors. For example, any other one. One more example is 27 is the number. In this 27, is 27 even number or odd number? Odd number. Odd number means you have to check with the 3. First you have to check with the 3 whether is 3 divisible in 27 or not. You have to check it. Yes, 3 is divisible. 3 9 ja 27. Again 3 3 ja 9. So 3 3 ja 9. Till getting the prime number you have to divide like this. So what are the factors of 24? Prime factor. These also the prime factors. Means only the prime numbers. So 24 equal to, just you write 1, 2, 3. 3 2s into 3. Again 27 equal to 3 into 3 into 3. These are the factors. So by using the prime factorization method, you can find out the factors of the given number. Those factors are also the prime factors. And these two are unique, different, both are separate. Now, so by using this prime factorization method, you can find out the prime factors of the given number. After finding the factors, you can find out the LCM and HCF of the given number. So how can you find out? For example, here HCF and LCM of 24 and 27. For example, this is the question. Now 24 equal to what we got here? 2 into 2 into 2 into 3. That means this can be written as 2 is multiplied 3 times. So this can be written as 2 cube into 3 is 1 time only is there. So 3 to the power of 1. As well as 27 equal to 3 into 3 into 3. That equal to 3. How many times multiplied here? 3 times. So this can be written as 3 cube. So here what is HCF and LCM? HCF equal to the product of the least common power of the common prime factors. That is nothing but HCF. The product of here see, just what is the least power here? 3 to the power. Any other common factor is there here? In both the numbers, any other common factor is there? Yes. What is that? 3. Here 3. But here 3 power 1 and here 3 cube. Here what is the least power? 3 power 1. Here also you can write 3 power 1. So HCF of both numbers equal to, what is the answer? 3 power 1. Least, the product of the least power of common factors. Least power of common factors, that is nothing but HCF. In both the number, 3 only the common factor and least power of that common factor is 1. So due to that, 3 to the power 1 here you have to write. So that value 3 to the power of 1 is nothing but 3 only. And LCM, what is that LCM value? LCM equal to the product of the, here the product of the highest power of each prime factor of the following numbers. Here 2 cube into here 3 to the power of 1 and here 3 to the power of cube. Here what you have to write? The product of the highest power of each factor of the following numbers. Here 2 cube into 3 cube. Here 2 cube, here 2 is not there. So each common factor highest power, you have to multiply that, the product of the highest power of each prime factor, each factor of the following numbers. That means 2 cube is the highest, here 2 cube is not there, 2 is there, 2 cube, right? And here common factor is there. Here for LCM, finding the LCM, not common factor, product of each prime factor. So 3 power 1, highest 3 power is 3 cube. So 2 cube into 3 cube you have to write. Where 2 cube equal how much? 8. And 3 cube equal how much? 27. Now multiply 8 7 ja 56. 5 keep in mind. 8 2 ja 16. 16 plus 5 21. So 216 is the answer. So by using that prime factorization method, you can find out the LCM and HCF of the given numbers. This is the answer. Next theorem is here, theorem number 3. Any of the rational numbers can be expressed in the form of decimal form. Some are the terminating decimals and some you will get non-terminating recurring decimals. So terminating decimals means terminating is nothing but it ends. Suppose 3 by 5, for example here, example 3 by 5 is the question. 5 means, is a 5 divisible in 3? No. So take 0. That means 0.5 is divisible in 30. 6 times 0.6 you will get. This is the terminating decimal. Suppose example 1 by 3. Is 3 divisible in 1? No. Keep 0 here. 1 after 0, 10. So in 10, how can you write? Is 3? 3 is divisible in 3 times 3 3 is 9. Again you will get remainder 1. So again take 0 here, 0 point. Why? Because here in the numerator 1 only is given. In 1 it is not divisible. So take 0, keep 0 here. Instead of this you have to write decimal point in the question. So again take 0. Again 3 times 3 3 is 9. Remainder 1. Again take 0. 3 3 is remainder 1. Always you are getting the remainder 1. So this is, what is the answer here? How can you write? 0.333. Is it terminates? And can you do more? Yes, you can do more. So this is not, it is not end. So you have to write 0.333 and so on. That means no end here. Terminating is nothing but you got 0 at the remainder. Non-terminating means no end. Repeatedly you are getting some of the answer. Sometimes repeatedly will get the same value. Sometimes different values you will get. So these are non-terminating recurring decimals. These are non-terminating. These are terminating decimal. So by doing of this division, you can find out whether the given number, rational number, is a terminating decimal or non-terminating decimal. But here, one of the theorem, 2-3 theorems are there. By using that theorem, you can find out whether the given rational number is terminating or non-terminating. Here just you have to assume that the given number, let x be a rational number. For example here, 3 by 8 or 3 by 7. Anyone we can take our wish. So this number you have to assume as x. This is in the form of p by q. So it is a rational number. So I am assuming let x be a rational number. So x equal to 3 by 8. Here what the condition, whose decimal terminates? What the decimal terminates? When the x can be expressed in the form of p by q, where p and q are co-prime numbers. The x can be represented or expressed in the form of p by q. Yes, p by q, where p and q are co-primes. So first, what are co-primes? Co-primes are nothing but both the numerator and denominator, they have only the common factor. Remaining numbers are not the common factors. One only the common factors means in both the numbers, any one common number is not divisible. Those numbers we call it as co-primes. Co-primes are nothing but one only the common factor, both numerator and denominator. So that means you have to simplify. For example, here 25 by 30 is a number. This is also rational number. So this is also in the form of p by q. So you can say that this is also the rational number. But you can simplify both the numbers. In both the numbers, 5 is divisible 5 times and 6 times. So 5 by 6. After simplification, whatever the number you will get, that we call it that in these two numbers, just you can say that co-prime numbers. Why? Because in both the numbers, any one common number is not divisible. So here you want the factors you will get. This 1, 5 are the factors, and here 6, 1, for 6 you will get 2, 3 and 6 are the factors. You have to just find out the factors are the numerator and denominator. So in both the numerator and denominator, which number is a common factor? One only the common factor. That means any other number is not divisible in both the numbers. You have to simplify and reduce the numbers and you have to write down. So these are co-prime numbers. Now here, example 3 by 8 I have taken. Here the number is in the form of p by q. Yes, where p and q are integers. Yes, p and q are integers. And these two are co-prime numbers. Yes, these two are co-prime numbers. And the prime factorization of q is in the form of here 2 power n and 5 power m. Here q is in the denominator. Suppose the q is in the form of 2 power n and 5 power m. Then where n and m are non-negative integers, then this rational number, this one is a terminating rational number, terminating decimal. This number can be expressed in the form of terminating decimal or non-terminating decimal. What is the condition of the terminating decimal means? These two are p and q are co-primes, and where q is in the form of 2 power n and 5 power m is there, then it is a terminating decimal. That is the condition. Entire the meaning is only here the given rational number here. The given rational number you have to assume as x. X is in the form of p by q. Yes, p by q, where p and q are co-primes. P and q are co-primes is nothing but reducing terms. That means any other common number is not divisible. Yes, already is given in 3 and 8. Any other number is not divisible. Any other common number is not divisible. So you can say that 3 and 8 are co-primes. Now q can be expressed in the form of 2 power n and 5 power m. Whenever this number can be expressed in the form of 2 power n and 5 power m, then you can say that it is a terminating decimal. You get the clarity? Now, see just how can you write that? By using the prime factorization method, you have to find out the factors of the denominator value. So, 8 is a given number, 8 is an even number. In 8, 2 is divisible 4 times, again 2 times. So, 8 can be written as 1, 2, 3 is there. So, how can you write? 2 into 2 into 2, 3 times 2 is multiplied by itself. So, 8 equal to 2q. So, this can be expressed as 3 by 2q. If the denominator is in the form of 2 power n or 5 power m or both 2 power n and 5 power m, then it terminates. It is terminating decimal. Suppose here any other number 3 by 7 is there. Just you have to check it. Can you write the 7 is in the form of 2 power n and 5 power m? Can you write? No. Why? Because 7 is a prime number and also it is a odd number. This cannot write is in the form of 2 power n and 5 power m. So, it is a non-terminating decimal. It is a non-terminating decimal. But 3 by 2 cube, it is a terminating decimal. It is a terminating decimal. Just you have to observe like this. It is a terminating decimal and it is a non-terminating decimal. If you like this video, please like, share and subscribe my channel. Thank you. Once again, thank you.